Good evening, everybody. Welcome to the library. I'm Heather Cimino. I work in the adult programs group here to bring you events like tonight. If you could take a minute to silence your phones before we get started, and also note the exit over here, which when the event is over might be quicker to get to the parking lot. Tonight we have a neurosurgeon with us to talk about common brain conditions as well as preventative measures that you can take to avoid injury and optimize your health. So we have Dr. Marc Otten here from Orthopedic and Neurosurgery Specialists, otherwise known as ONS, and he is also a fellowship-trained, board-certified neurosurgeon, and he specializes in brain and spine. So please put your hands together for Dr. Marc Otten.
Thanks so much, Heather. Thanks so much, everybody, and thank you, Heather, for the introduction. I was talking with the team here about what would be interesting to everybody, and I will say that this is going to be a little bit of a whirlwind, what I've put together to present tonight, and we could easily make a lecture or even an entire course on almost each of the subtopics, but I wanted to keep it somewhat broad, but also useful to you all. And so if there's a value to diving in deeper, just stop me, ask questions. I'm fine with that. And we can stop when the time comes or when people start to leave or however you wish. In terms of what I aim to communicate is my overall message here is an emphasis on health span. There was actually, I think, yesterday in the Wall Street Journal an article about how in the United States, lifespan is increasing, but health span is shrinking. And so that takes some definitions. I think we all can imagine what lifespan means. It's just the amount of time that we're alive. Health span is defined in different ways. It's a little harder sometimes to nail down, but the idea is how long we are functioning, the way we want to function. And that's, I think, what most of us want, more even than lifespan. So it's a great concern that it's shrinking. So that's going to be what I'm going to focus on. As the comedian Bill Maher said, the answer isn't another pill. The answer is spinach. And the other point I want to make along those lines is that there's an enormous industry that's only growing that offers a lot of promises. And, look, I think the concept of snake oil is not a new one, and a lot of it is very meaningful, but it's probably not going to be in a pill. And that's what I just had, and happy to share if anyone wants. It'll freshen your breath, if not your... Nevertheless, people are trying. And this is a list that's entirely too small to see. From the National Institute of Aging, a series of studies that are currently 106 trials that have been tested in mice to look at the impact on lifespan. And they found improvement. Aspirin, this is the list. I'm not going to go through it all. And some of this is ongoing. And this really focuses on exogenous compounds, right? Things you can put in a pill and take and can potentially have an impact on lifespan. I studied stroke when I was a resident and looked at a series of compounds that were modulating the immune system and things that we could do to reduce the burden of stroke. And I will tell you, we made stroke a lot less of a problem for mice, but unfortunately, we are not mice. Maybe fortunately, I'd say fortunately. And one of the things that's really important is over the last 25 years, the access to information has absolutely exploded. Unfortunately, the way of evaluating the fidelity, the accuracy of that information has not quite kept pace. And so we're constantly bombarded with information, but we don't always know what's legitimate and what's not. And there are methods. The peer review process is very powerful, looking at the quality of trials. Search engines, right? Google exists because it was able to do better than Yahoo at telling us, giving us useful search responses to our searches, and that's evolving even more. But I wanted to give a little background on me, right? If I were here to talk to you about male pattern baldness, you probably would be skeptical. And the question is, well, I'm going to talk about brain health. Why listen? And so I want to give a little background. I studied actually philosophy in college. This is from the Metropolitan Museum of Art. It depicts the killing of the Minotaur by Theseus. And the reason I bring it up is that was a story that was really, it got me thinking quite a bit. And it wasn't so much the myth of Theseus, who unified the local settlements of Attica into a political and economic entity that we still call Athens. And in terms of I'll give a little background. The Minotaur was kind of the guardian of King Minos of Crete, and each year the citizens of Attica and what became Athens would have to send sacrifices, and this half man, half bull would tend to devour him. And Theseus volunteered. He was the son of the king, and he volunteered to go and, well, have a go at trying to kill the Minotaur. And he befriended the daughter of Minos, Ariadne, and she gave him the string. I mean, some of you, I'm sure, know this story. And he went through the labyrinth and was able to kill the Minotaur and find his way out. Picture here is, unfortunately, of Theseus abandoning Ariadne on his way back to the myth, the thing that got me interested. And you might be wondering, well, what does this have to do with neurosurgery or the brain? Each year, the citizens of Athens would take a pilgrimage with the ship of Theseus. And over the decades and centuries, that ship, well, parts of it would rot. Right? And so they would replace them. Where this comes up in philosophy is bit by bit, you're replacing all the parts of the ship. Is it still the same ship? And it does carry the same form, but it is not materially the same thing. And this is very similar to people, right? What is it that makes us who we are? From the time we're born, or even before that, when we're a single cell, to the time we're born, and as we grow up, and as we develop different relationships, our cells are constantly being replaced. In fact, we have about 30 trillion cells, it's an estimate, in our body, and about 330 billion of them are replaced every day. And so about 1% a day, over the course of 100 days, you could say, well, we've totally turned over our cells. Now, the truth is, some cells don't replace like that, and the heart and the brain are among them. What makes a person a person? Is it the cells? Is it their traits? Is it their memories? The point is that this got me interested. And as I went off to medical school and was studying the different parts of the body, I was coming at it with an interest in what it is that makes us human. And the brain is, well, what I concluded, and I think it's very, very reasonable, and certainly what's very different between us and mice and other animals. Familiar to everybody? Anytime you want to check out, having bought something, this is a CAPTCHA. It's a completely automated public Turing test to tell computers and humans apart. And it's asking to click on the boxes that have the traffic lights, which for a human is relatively straightforward. Admittedly, some of these I have a hard time with. It's something that's impossible for a computer. This is a drawing of a squirrel, right? And I know it's semantics, but it's important. And the reason it's important, from my perspective as a neurosurgeon, is that the process in the brain, taking a picture like this and deciding what it is and deciding what to do about it, is really important. Again, I disagree. A picture of a squirrel this time. The point is that process of seeing something and being able to identify it and understand the question and answer the question that a normal person would be asking, which is, what is this? It's squirrel, right? Not a picture or a drawing of one. Takes certain leaps that computers tend to have a difficult time with, although that is changing. And ChatGPT is one of many now of these AIs that are of great interest in changing everything possible. But in terms of my interest and what I do, and that's why I'm here in front of you, is I'm a neurosurgeon. And so I study the nervous system, the human nervous system specifically, and take care of what are generally structural problems that involve surgical pathology. So the modern neurosurgeon will work in an operating room. This is a picture of one with a microscope and special navigation equipment, and this is a tubular retractor. We're constantly trying to come up with ways to access parts of the brain that are having problems without causing damage to other parts of the brain. Schematic of the modern operating room. And this is all towards our goal as neurosurgeons, are to maximize safety and accuracy so that we can help people return to their lives as close to what they want as possible. And so, much of a surgeon's training is in the operating room. I think it requires, to do our job properly, a real understanding of our individual patient in front of us and what it is that makes him or her want to live, and try to get them back to that as quickly as possible. So that's the background, a little bit about me, and you can decide. Certainly, I hope you'll continue to be skeptical of anything I have to say, but that's the context in which I'm up here talking. A little introduction to the brain before we can talk about how to hold on to it as long as possible. And it's a little bit of an arbitrary classification system. but not entirely. And this comes from the NIH Division of Neurological Disorders and Stroke. But we have lobes, right? The frontal lobes, the parietal lobes, temporal lobes, cerebellum, occipital lobes, the motor and somatosensory cortex, but it's not really all so discrete as that. But these definitions are important and useful. And when I say it's not as discrete, the brain is really networked, and there's certain redundancies. The lobe concepts come more from the fact that if you have damage to a certain area, you can have discrete deficits that we can identify. For example, the motor cortex here at the back of the frontal lobe is the primary initiator for movements, but you can have, so if you have a damage in that area, you might have frank paralysis, but you can have damage in other areas that don't paralyze but might affect the person's ability to pick up a cup or use it to drink, and so on. Networks here. But there is a structure that elucidated by understanding the lobes. So information comes in, right? Our bodies, our eyes, our skin, our ears, our senses of smell, they all provide sensory input that gets brought into the brain. And vision is a helpful one, right? So you see that picture of the squirrel. The eyes are up here, right? And not even in the picture, but they send a signal back to the occipital lobes that actually create a picture, almost like you would see on a old school photography film, right, where it's actually superimposed, it's flipped. So now you have light but now you have to interpret it, right? Is that something I'm familiar with? Is that something that I have to be worried about? Is that someone I know? Is it a person? Is it something else? And that is where the parietal lobes process that information into more than just light signal. The temporal lobes tend to do that with sound. And are integral to processing that into speech or understanding speech or sounds that aren't speech, that are garbled. And then the frontal lobes are really what make us most unique in that they're extremely developed in humans, at least what are going to give you the ability to make decisions, right? To take all that information and you just got cut off and no, I'm not going to pull over and try to start a fight here, or I'm going to forgive my daughter, or whatever it is. And so that processing some of those higher decision-making processes. Deep in the brain, so you've probably heard of this concept of the brain stem. The idea there is that you've got the cerebrum and the cerebellum as the petals of the flower. And the stem are these fundamental areas of the brain stem. And this is really important, diagrammed here. The areas called the thalamus, the hypothalamus, the hippocampus. They're actually not that different in some cases to other primates and even other animals. That, in terms of how the neuron works, there are a lot of cells in the brain, in the nervous system. Neurons, though, are really the primary transmit information. And they're made up of cell bodies with the nucleus, the wiring, which are the axons, and here you see the myelin, which is like the insulation, right? Just like you have on any wire, you know, the metal's inside. And then the axon terminal, and these will often branch to additional neurons or potentially to muscles and other areas that you know, could be the heart muscle or in the gut, that they will send signals, cells to act. And it does it, so there's an electrical impulse along the axon, and then neurotransmitters are released into the synapse and then taken up by the next cell with appropriate receptors. So you've heard of serotonin, selective serotonin reuptake inhibitors, inhibiting the reuptake of serotonin, and that is, complexity comes from the ability to secrete more or to reduce the reuptake. The mechanisms can get very complicated. And this, although neurons don't tend to reproduce, once you reach a certain age, they don't recover when they've been killed, there is still a substantial amount of plasticity and change, and that occurs junction between two neurons, and then also with the way dendrites. They are extremely plastic. Within neurosurgery, our goal, to make it safer, we take what we have learned about neuroanatomy, we use it to figure out the ways to get to areas of the brain that we need to reach with maximal safety. So this is purely looking at language, and you can see the different networks schematically related to language. And what I was saying before related to the squirrel and identifying as a picture of a squirrel or a drawing of a squirrel, it can also manifest as reading sentences and understanding with syntax and different punctuation what's being communicated, and the ability to actually generate speech. All of this is a pretty complicated network, and one that our understanding The idea here is I'm trying to illustrate what an MRI is. Okay, an MRI is a way of looking inside the brain. If you think of the brain as a loaf of bread, the MRI provides the slices. And so in each individual picture, so this is sort of like on the left of each of these, the overall brain, and then on the right. So if you have a slice like this through the brain, you can see the eyes and the temporal lobes right behind the eyes, and you can see there's some asymmetry. You see that bright area on that side compared to the other? And that's, in this patient's situation, a tumor. So the goal here is to get it out right in areas that are critical to language in the temporal lobe. So how do we do that? So we can do a lot of mapping. I'm not going to get too deep into this because you didn't how we do brain surgery. You want to hear about how we can hopefully maintain brain health. Just as some background, we do it by, well, getting people awake. And this is a picture from the operating room where we have a patient who is resting, and we numb up the area and actually can sedate the patient to just, because we don't need to do much testing yet while we get set up, fix the head in place and then drape so that the surgeon is on one side of this drape and the patient and the anesthesiology team are on the other side. But they have access to the patient's eyes and ears and mouth and arm so that they can do motor and sensory testing. What we will do is we'll map out, this is on the surgeon's side, we have the brain exposed. This is that temporal lobe. The patient is, so that left temporal lobe is here. The eyes would be up here. And the frontal lobe is here, and it's in this area that a lot of the speech network is focused. The tumor is over here, and the margins of it are delineated by these little silastic. And while the patient is identifying and reading and interacting with the neuropsychology team and the anesthesiologist, on the other side, we have a bipolar, just means two leads, stimulator, and we're stimulating parts of the brain. And in areas where the speech is arrested, we'll place a different marker so that we know that this is part of the speech area. And we can, everything from syntax to vocabulary to different languages to musical interests, you can really map, well, almost anything you can do with a person, calculations and so on. So this can be a really valuable tool for surgery where we're trying to get out as much tumor that's infiltrating the brain as possible without causing harm, right? This patient, again, wants to get back to her life as usual. There are other methods we have for mapping as well. This is one with a patient asleep and it's sped up, but we give a special dye intravenously and use a filter to be able to light up the vessels of the brain. And you can see here the tumor as separate from the normal brain tissue. These are some of the methods to map the brain that we have. Other things that we do focus on technology. So this is an example, this is a schematic where we have a specific lesion in the brain that we're trying to get to. We use the preoperative imaging to plan a safe trajectory, and then we're able to make literally a pinhole, well, not literally, but a very small, about a 2 millimeter hole. We're able to use this frame to very precisely target. This is a bolt that we screw on, then we remove this positioning system, and we're able to actually place a laser probe into the brain, and then put the patient in the MRI scanner. This is the going in. The patient's now in the MRI scanner. Here's the laser cable coming all the way to the control room where you've got the radiology technologist generate a heat map using the MRI and in real time, very precisely target the lesion without having to go after any of the surrounding structures. And this shows, again, the schematic of heating up and taking the tumor out of viability without any significant harm to the patient. This kind of thing you can go home the same day, and it's really, we owe a lot to the technology. This is another form of technology, and I won't show the whole video, but this is using an endoscope. We have a very small probe again that brings us deep inside the brain. This is inside the ventricles. I'm sorry, it doesn't project as well as it should, but this is deep inside the brain. That's the fornix, and you can see as we come into the third ventricle. This is the mammillary bodies and the infant. These are just other structures within the brain that we can see with minimal trauma. So let's move to maximize the health span of our brain. In this regard, I'm going to do a little more background with how our brains develop, okay? And this is looking at, over the course of childhood, different parts of the region, different regions of the brain reach peak volume at different ages. And so these are the color map for the ages, and you can see some areas develop much sooner than others. And the point about that is that the brain develops, right? So here you've got in red the insula, which is that area where speech is generated, which is the latest to develop. And the earliest is the parietal lobe in blue. And really, you're talking about a peak right around age 7 to 9. Age 7 to 9. It's in that context, the rest of life is kind of downhill. And likewise here, you have the peaks of different parts. Gray matter volume, white matter volume is the only thing that really goes up later in life. And that's the ventricular volume, which is because the rest is atrophying. So that's just how it is, okay? And I don't have a pill to change that, but what we want to do is affect that curve of deceleration. And I think we all know that we don't peak in wisdom in our early 20s, right? And that goes to your brain volume and even connectivity aren't the only or even the most important things towards being able to function and have the life you want. There's a lot more to it. And so learning to compensate and also learning to use whatever brain volume you do have in a meaningful way. How can we minimize the slope of the basics, okay? So I think this is actually an ad, but I'm using it to illustrate the opposite, which is we do know smoking and drinking we were hoping that drinking wasn't all bad, right? But even that looks like it probably didn't pan out. And so if you can cut cigarettes and alcohol out, it's kind of the first step. Much of what I'm going to say now, I don't know if there's any popularity to what I've said, but it's not popular, and that's because it's the kind of steps you're trying to minimize the slow decline of things, but it's not, you're not going to get immediate results, right? And that goes to the next next recommendation, which is exercise, right? And there's no pill for physical activity. And, I think Schwarzenegger and Bush inspired us, but maybe didn't do everything. The point is that's one of the things that has been shown to be really valuable. Through exercise, you really want to focus on 3 major parts of it, and I'll get to that. But there really is data behind this. This is from a study that looked at control groups versus exercise groups. Executive function, controlled tasks, spatial function, speed of mental tasks, all were much higher in those that regularly exercised. And I have this quote from Nietzsche at the time, all truly great thoughts are conceived while walking. And that goes a long way with this. And what I was talking about the different things you can do to exercise. I think most of the people in this room fit into these categories. Exercise doesn't mean that you need to get your heart rate up to its maximum capacity. The kind of benefit we see with this is getting heart rate, your exertional level, up to a point where you're having a hard time having a conversation, right? Where it's a little uncomfortable to talk. So a brisk walk is great. And you want to be doing that. We see a difference at about 150 minutes a week. And so that can often be 30 minutes a day for 5 days of the week, slightly longer intervals. These are all options. But these are the recommendations and will really make a big difference. And that's going towards your ability to move oxygen to your cells. Other aspects that are really important are keeping muscle mass. That's something that's going to decline as we age, and having adequate protein and having weightlifting as part of your regimen. And then also just balance. So 36,000 deaths, this was in 2020, but in a year, in people over the age of 65. And so this is a major, this goes to balance, right? As our senses decline, as our ability to process that information declines, we're much more at risk of not catching ourselves if we trip off the curb, trip in on the rug. That goes to the kinds of interventions that we can focus on. So we talked a little bit about exercise, strength, balance, maximizing oxygen capacity. Some of it is just not all that sexy, but having home modifications, right? Having an occupational therapist do a home visit, careful about slippery and uneven surfaces in the home, having lighting so that you don't have poor visibility, leaving a light on in the bathroom so that I see a lot of patients who come into the emergency room because of that fall from, in the middle of the night trying to get to the bathroom. And then making sure that rug edges are down or gone, and managing steps in the home. And then clinical. One of the things that all of you I can recommend you do is see your internist. Have a long conversation about what you can be doing to minimize risks. And we often add medications. We rarely remove them in medicine. But having medications that have psychotropic effects, making sure if you have cataracts, they're managed, pacemakers for people who are having episodes where they're called syncope, where you lose consciousness, gait problems can often have reversible causes, and then bone density. These are all things that you can work on with your internist and require that you start as early as possible. That's to physical health, but there's an inextricable tie between physical and mental health. And to that end, I'm going to talk a little bit about, and again, these are topics that I'm going to race through. We could spend a lecture series on them alone. But with regards to mental health, temet nosce. And for some of us, we think of the Matrix when Neo walked into the oracle's room. But for most of us, this is an old adage of know thyself. And for mental health, it has a lot to do with understanding the kind of person you are and the kind of environment that you ought to be in. This is a library talk, so I thought I could plug for some books that I had nothing to do with. This comes from Arthur Brooks. He's published a few books. He and Jonathan books about one. His was called The Happiness Hypothesis, taken from Arthur Brooks. And he looks at how people, stronger feelings about negative emotions, stronger feelings towards positive emotions, relatively even-keeled, versus kind of very strong negative emotions and not so strong positive emotions. And he breaks those into the mad scientist category, or the ones with strong positive and negative emotions. The judges are very even-keeled, not so strong of either, and then the poets and the cheerleaders as well. And there's a place, it's not a good or bad. The idea is that these, if you know yourself and what of these categories you fit into, you can work to that, right? You know that you're a mad scientist. You're going to get super excited about things and then really depressed about things. Maybe having a judge in your life to keep you a little even-keeled is worthwhile. But also just knowing yourself and understanding what you're doing. And likewise, the poet. My daughter's one of these, and kind of getting lost in sadness about certain things without recognizing that while it might help your writing, it's not it's hard for everyone around you and yourself. And likewise, and this is just kind of, I'm not going to get too deep into this, but other things that have been shown to be very valuable. This is a plot. Now, historically, I've given mostly talks to medical students and residents and other doctors, so this is a new audience for me. Hopefully I'm keeping you guys engaged, but I can't help but put up a little bit of data. And this comes from a study looking at who were placed on a pretty intensive mindfulness-based stress reduction routine versus Lexapro. And this is over time. You can see that pretty similar in terms of their reduction of, this is an anxiety score, of reducing anxiety. Case, it is a pill, and the mindfulness-based stress reduction course is about 45 minutes a day, so you can imagine why it's hard to do that. But there are different ways you can approach your mental health. It's not always with a pill, but some of them are very time-intensive. Sleep is another critical component of brain health, and I think it's from like some, I don't know what you would think it's from, but it turns out this is from the Air Force Materiel Command, and this is what they have on their website, and they're the ones who really manage Patterson Air Force Base in Ohio, the Air Force's mission support, discovery and development from health to their supply chain. So they get it, and so we should too, the importance of sleep. A little bit about the anatomy of sleep, largely regulated, and a lot of it has to do with light coming in to the parts of the hypothalamus and the pineal gland, and initiates certain activity in the brainstem. I mean, this is something that all animals do. I remember back in medical school, I thought if I could only figure out a pill that could avoid sleep, and I actually see someone in the audience who came as close as anyone I've ever known to doing it, it would be great, but unfortunately, something that all animals at all parts of Earth seem to do, it's going to be hard to beat that with a pill. And there are rhythms related to it. So this is the melatonin curve, and this is our body temperature curve, and it's approximately a 24-hour cycle. And it's just not something that we can really cheat. It's not the same for all of us, for all of our lives, right? Average sleep need, approaches 16 to 18 hours. As children, it's probably more than our schools allow. And as adults and older adults, it probably does diminish. It's important for brain health over time. This was a study looking at, and this is a study that's really observational, right? So it's hard to know cause and effect in this. This is more correlation, but looking at, these are cognitive functions, and on the x-axis of each of these is sleep duration. Here high is good, here low is good. The peaks tend to happen in that 7 to 9 hour. So people getting about that much sleep had the highest levels of cognitive function, and likewise, right in that same range, these are mental health measures, anxiety symptoms, depressive symptoms, et cetera. But the point is that in people getting the range of 7 to 9 hours of sleep, I wanted to emphasize this is correlative because it doesn't mean you should go home and get exactly 7 to 9 hours of sleep and you're going to be all fine, right? Sometimes people who are depressed are going to be sleeping a lot longer. There can be underlying disorders that lead to a lot less or a lot more sleep. I think we can all acknowledge, and there is data to support that healthy sleep is important. And these are some tips. Back to books, there was a professor out at Berkeley who really has some good tips about what you can do. And it's nothing crazy. It's, set a schedule, having some consistency. While exercise is good, you want to avoid it within a few hours of going to sleep. Avoid caffeine and nicotine late in the day, and certainly alcoholic beverages. That's one thing about alcohol is it really changes your sleep architecture. On one hand, if you're going to drink, it's not supposed to be in the middle of the day. On the other hand, you shouldn't be drinking after 6 p.m. So trying to relax before bed, trying a warm bath or reading. I showed you that temperature curve before, so taking a bath will help your capillaries dilate and help you with that routine. Creating a room for sleep that's dark, that's a little bit cool. Optimal temperature is usually in the mid-60s, which is lower than what my wife would allow. But not having a TV or other distractions in the bedroom. If you're having trouble sleeping, don't just lie there. Get up, walk around. And if you're having significant problems or you're exhausted during the day, it could be the sign of an underlying condition. And next big one I'm going to talk about. So we've got sleep, we've got mental health. Exercise. No shock that nutrition would be on that list of things we can do. These quotes, this is from Hippocrates, our food should be our medicine and our medicine. The thing about this is that we kind of know what we should be eating, maybe not. We know that a lot of food manufacturers have developed to make us want their food. It might not be so good for us. We live in an unusual time of food just isn't scarce, it's overabundant. But the studies on food and the science behind it, a great study that was done where they really intensively had people doing a Mediterranean diet versus just a diet, a calorie-restricted diet, and they looked at the changes in global cognition score in both groups. Being mindful of their diet helped, right? These were a small change in their scores, but it wasn't statistically significant. And likewise, adverse events weren't statistically significant. Now, it was just a 3-year study, and a lot of these changes we're talking about are the kinds of things that if you eat whole foods and whole grains and a Mediterranean diet, you're maybe going to add healthy years over decades. So it's hard to study this kind of thing. So it's not to say you should just abandon it anyway, but high sugar added foods, don't do that. Anyway, so I think there's a certain amount of common sense here. There's definitely correlations, but I can't recommend a specific diet. All right, so to understand how these things might health span with regards to our brains, we want to understand a little bit about how we age. These are theories, right? Again, this is such a long-term process that it's hard for us to know for sure. But the idea here is that over the course of a lifetime, we accumulate damage. Our bodies have an ability to scavenge cells that are sick and can do a certain amount of repair, but particularly in the brain, there's a certain amount of... And the idea behind a lot of these interventions is to change the slope of that curve, right? This is the accelerated brain aging. This is kind of our threshold, right? When you get beyond this, you're not able to compensate. And you're not able to compensate means you might become dependent for things that meaningfully you were independent on before. You might not be able to prepare your meals or safely get around your house or live alone or drive. The idea behind these measures is to drop that curve so that you delay. So the same thing, there's over the course of a lifetime, declines in our brain network and things that measures we can take early on, education, learning additional languages, remaining social, eating well, exercising, and so on, are going to push that curve to the right, delay that aging process. And this is a group, a wheel of things that we can do, and it kind of summarizes what I talked about today, and so I wanted to, and they have, a clever ABCD. Being aware of the kinds of things, right? I mean, as much as we don't have great data behind nutrition science, understanding the things that are risks, understanding that falls are a big concern and avoiding them is important. Seeing your doctor early, knowing if you have, there are 100% modifiable risk factors, right? We kind of know that with cardiac disease, right, and heart disease and cardiovascular disease in general, and with the brain, they're very similar, the kinds of risk factors and problems we have. And in fact, a lot of in the brain are likely related to cerebrovascular disease. But that's important. Community engagement, we're social animals, and there's definitely evidence that environmental problems, and I don't mean here the temperature of the earth as much as we talked about, glycemic control is connected to that, and that is, there we can be very, I don't know if any of you have heard of or read, this is another, I guess, again, I have no skin in the game, but Peter Attia is a well-known personality. He recently published a bestseller called Outlive, and he is a proponent of continuous glucose monitoring. And it's not because it's something that necessarily you need to, if you're not a diabetic, you need to do. It probably isn't cost effective, but he talks about the Hawthorne effect, the fact that if you understand how what you're eating and what you're doing affects your blood sugars, and when you're watching yourself, it gives you information. Hyperlipidemia, managing your cholesterol levels both for your heart and for your brain. To summarize, number one, get rid of the destructive habits, smoking, alcohol, and exercise. Focus on mental health and social engagement. That's what I had prepared here.
Thank you very much, Dr. Otten. Much appreciated.
Thank you.